Hi boys and girls, welcome to my physics classroom. I hope you all have a great day today because we're going to cover an interesting topic I like to call Newton's laws of motion. Yay! Okay. Anyways, so let's start today by covering the three laws themselves. First law, objects at rest stay at rest unless acted upon by an outside force. This means that a force needs to be applied to an object in order for movement. Our next one of Newton's laws of motion is force equals mass times acceleration. This is showing that every force is dependent on the mass of the object being moved and the acceleration, or how fast it will actually go in order to make force. Don't act too happy, guys. I know you're very excited by this. Finally, for the third law of motion, for every action, there is an equal and opposite reaction. Is there any questions, class?
Mr. Woods!
Yes?
How does this relate to real life?
Well, I'm glad you asked. How about we go outside and I'll show you Newton and how it applies to the real world. Since you wanted to know how Newton's laws apply to the real world, let's start with the first law. Do you remember what the first law of motion was?
An object at rest stays at rest unless acted upon by another force?
Yes. Okay, Amber. Let's take, for example, the skateboard. Right now, is it moving?
No.
So is there any forces being applied to it?
No?
Exactly. Okay. How about now?
Yes.
Now, what force was acted on?
Your foot?
Exactly. You were very smart, Amber.
Yes.
Okay, Amber. Do you remember what the second law of motion was?
F equals ma?
Yup. Force equals mass times acceleration. Now, Amber, which car do you think will have more force? If they have the same mass, do you think the one going slow will have more force? Or the one going fast will have more force?
I would say definitely the awesome pink slow one.
Okay, let's put that to a test. Here's the slow pink one. Now here's the fast yellow one.
Ouch!
Alright, Amber. Which one do you think had more force?
I think the yellow one did because it definitely hurt worse when it hit my arm.
That's right. The acceleration increased and the mass stayed the same. The force increased for the yellow car.
That makes sense. You're such a good teacher, Mr. Woods.
Thank you. You're just a good student, Amber.
I know.
Alright, Amber. Now, do you remember what the third law of motion was?
For every action, there's an equal and opposite reaction.
Yes.
So
Now,
smart.
yes, you are. Now, if these cars collide in the same force, what do you think will happen?
They're just going to stay in the same place.
Alright, let's see if that happens. As you can see, the yellow car and the pink car hit and then bounced back. Therefore, it was equal and opposite.
I get it now.
Good, good. Now, class, now that we actually saw how this applies to real life, let's go over them again and use the examples we saw outside. For the first law of motion, we saw that objects at rest stay at rest unless acted upon by an outside force. Remember the skateboard? Yeah, that was an awesome example. For the second law, we saw that force equals mass times acceleration. Remember the car being pushed slower than the other one, having more force when it hit Amber? Yeah! And finally, the third law of motion, for every action there's an equal and opposite reaction. Remember when we crashed the cars together? We got that awesome just rebound off the two of them? I hope this answers your questions on how Newton's laws apply to real life.